Why are vacuum energy devices so difficult to engineer? Imagine trying to tap into a force so tiny that it's almost impossible to see, yet it's everywhere around us. That's what engineers face when working with vacuum energy devices. They aim to harness the energy in the quantum vacuum, which is not empty but filled with fleeting virtual particles and tiny energy shifts. The problem is, these fluctuations are incredibly subtle and weak. Extracting usable power from them requires manipulating effects at scales and precisions that current technology just can't handle yet. The quantum vacuum is like a bubbling foam of energy constantly fluctuating. These fluctuations produce forces like the Casimir effect, which has been observed in labs. But turning this tiny force into a steady, reliable energy source is a whole other challenge. The forces involved are so small that even the most sensitive instruments struggle to measure or control them. To make a device work, engineers need to create nanoscale gaps and structures with extreme precision. Think about building a device with parts just a few nanometers apart. That's 1,000 times thinner than a human hair. Another big hurdle is maintaining the right environment. Vacuum energy devices need ultra-high vacuum chambers that are almost completely free of air and contaminants. Achieving this involves complex and costly equipment that can run for long periods without losing vacuum. These chambers often cost thousands of dollars to build and operate, and keeping them stable is tricky. Any tiny leak or disturbance can ruin the experiment. Designing materials that can manipulate vacuum fluctuations is also a major challenge. Scientists are exploring special materials like chiral cavities or doped semiconductors, which can influence quantum effects. But creating these materials involves extensive testing, simulations, and trial and error. It's like trying to craft a perfect puzzle piece that fits just right at the quantum level. Scaling up these devices from small experiments to practical power sources adds another layer of difficulty. Many prototypes requiring extreme conditions like very high temperatures or powerful magnetic fields. These conditions make the devices bulky, expensive, and hard to operate outside a lab. Miniaturizing them while maintaining efficiency is a huge engineering puzzle. In the world of strange experiments and mysterious forces, vacuum energy devices sit at the edge of science and engineering. They often produce quirky results, like tiny forces or unexpected energy fluctuations, that seem to defy common sense. But turning these strange effects into reliable, usable energy remains a major challenge. It's a mix of pushing the limits of materials, precision engineering, and understanding the deepest laws of physics. That's why, despite all the promise, making practical vacuum energy devices is still a long way off.